You ever noticed how some websites seem to, I don't know, read your mind? They load almost before you've even finished clicking? Well, today we're going to pull back the curtain on the secret sauce that makes it all happen: caching. It's the invisible engine of the fast web, and trust me, by the end of this, you'll start seeing it everywhere.
Right? It's a feeling we all know. That first visit is fine, but the second time around, boom, it's instantaneous. So what's the deal? Is it some kind of magic? Not quite, but it's close. The answer is a really clever trick called caching.
So let's just dive right in. Caching was born from one simple fundamental truth about the internet. Speed is everything. We hate waiting, and caching is pretty much the ultimate weapon in the war against that dreaded loading bar.
And this slide just lays it all out perfectly. Over on the left, without a cache, your request is like sending a tortoise on a cross-country trip. It has to go all the way to the main server, which then has to dig through its database. It's this whole long, slow journey. But on the right, with a cache, man, that's a superhighway. The cache acts like a little local depot that has exactly what you need, ready to hand it over in a flash. Okay, so how do we really get our heads around this? I found the best way to think about it isn't in terms of computers, but in terms of your own physical workspace.
All right, here's the official textbook definition. Caching is storing copies of frequently accessed data. Let's just break that down. Copies is the most important word here. It's not the original. And frequently accessed is the why. We only bother doing this for the popular stuff. The whole goal is to have it ready to go in a temporary, high-speed location, so any future requests are just way, way faster.
And this is the analogy where it all just clicks. Think of the main database as that dusty old filing cabinet way down in a dimly lit basement. Every time you need a file, it's a whole trip down the stairs, you're fumbling for the right drawer, it's just a pain. The cache, though, the cache is at the top of your desk. You've got the exact files you're working on right now, sitting right there within arm's reach. That's the feeling of caching. Totally effortless and immediate.
Okay, so we get what it is, but where does this stuff actually happen? Caching isn't just one single thing. It's actually a layered system that works at multiple points between you and the data you're trying to get. Let's follow that journey, starting with what's closest to home.
So the very first and most personal layer of caching is happening right now, inside your web browser. It's cleverly saving things that don't change very often, like logos, icons, the basic layout of a website. That's exactly why when you go back to a site, its whole shell seems to appear instantly. Your computer is just pulling those files from its own local storage.
Next up, let's zoom out to the global level with something called a content delivery network, or a CDN. Just think of it as a worldwide network of copycat servers. They store all the big, bulky files, like videos and huge images. So if you're in Lagos watching a video from a company that's based in California, you're not actually streaming it from all the way across the ocean. A CDN places a copy on a server right there in Nigeria, which makes the whole experience smooth and buffer-free. It is a total game changer.
And finally, we arrive at the source, the website's own server. This is where the application itself gets really smart. Picture a massive e-commerce site. Maybe millions of people are all searching for top-selling headphones. Instead of going back to that slow filing cabinet, the main database, every single time, the server keeps a copy of that search result in its own super-fast desk drawer. That's server-side caching, and it saves the database from a mind-boggling amount of repetitive work.
So, with all these different layers, how does the system actually decide when to use the cache? Well, it all comes down to a very simple, very fast decision that happens millions of times a second all over the internet. So, what does this system actually do? It's a quick little three-step dance. Step 1, a request comes in. Hey, I need this piece of data. Step 2, the system doesn't just run off to the database. First, it smartly checks the cache. Do I already have this handy? And that leads right to step 3, the big moment, the outcome. And this all leads to one of two simple outcomes. If the data is in the cache, we call that a cache hit. That's the jackpot. You get what you need instantly. If it's not there, it's a cache miss. Now, that's no big deal. It just means the system has to take the slightly longer route to the main database. But here's the really clever part. Once it gets that data, it puts a copy in the cache, making sure the next person to ask for it gets a cache hit. So, caching seems like a total silver bullet, right? Faster websites, happier users. What's not to love? Well, like any really powerful tool, there's a crucial trade-off. It's this constant battle between two competing priorities: speed and freshness. The wins are huge, and this table just lays them out perfectly. You get faster responses, which makes everyone happy.
You put way less stress on your database. I mean, we're talking reductions of 80, even 90%. That means your app can handle way more traffic and scale up easily, which, at the end of the day, saves a boatload of money on expensive hardware. It's a win, 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 win.
But here it is, the dark side of caching, the catch. The single biggest problem is serving what we call stale data. Imagine seeing a product listed as in stock when it literally just sold out. Or seeing an old profile picture for a friend who updated it 5 minutes ago. That's a bad experience. And on top of that, managing when to throw out the old data gets pretty complicated. And the super fast memory that makes caches work, well, it isn't cheap.
And this quote just perfectly captures the whole dilemma. It's a tightrope walk. To manage this, developers set an expiration date on every single piece of cached data, something they call a time to live, or TTL. If that TTL is too long, you get stale data. But if it's too short, the cache is constantly emptying itself out, and you might as well not have a cache at all. It's all about finding that perfect Goldilocks moment.
And that really is the central question that caching forces us to answer. I mean, think about it. When you're scrolling your newsfeed, you want the absolute latest information, right? You'd probably sacrifice a millisecond of speed for up-to-the-second accuracy. But for something like your own profile page, which doesn't change much, yeah, instant speed is probably better. Every single time you use an app, a developer somewhere has made that exact choice for you. So the next time a page loads in the blink of an eye, just take a second to appreciate that invisible dance of caching happening behind the scenes. It really makes you think, what is more important?